Hi Tate, here you need help on problem 8.4.26. So I am here to help you out. So we're trying to compare two different storage tanks. They both, one of them has a circular base with radius r and a height of r. So we can either do cylindrical like this with a base of radius r and a height of r. Obviously, this isn't really drawn to scale. The other one could be a cylinder, or sorry, a sphere with a radius of r and kind of like a height of r. So they have given us the information for the hemispherical, or for spheres, and we'll have to find the equations for the cylinder in a little bit. For part A, it's asking us what's the volume of a hemispherical tank, so we're really just taking half of this tank. So we're going to do half times 4/3 pi r cubed. And can distribute that half in. So we get 4/6 pi r cubed, which simplifies to 2/3 pi r cubed, which is how I got this answer here. And then if we know that surface area is 4 pi r squared, that would be for the entire outside of a sphere. But when we cut that sphere in half, it's going to have this circle at the bottom that's also going to contribute to its surface area. And so we know that the area of that circle is pi r squared. And we would need to add that to the half of the surface area of the sphere, which is 4 pi r squared. So half pi r squared plus half of 4 pi r squared plus pi r squared is 3 pi r squared, which is how I got this number here. Okay, so then what it's asking us to do from there is it's asking for us to write a ratio of the volume to the surface area, which puts volume on top, so 2/3 pi r cubed on top, and over the surface area in the bottom, which is 3 pi r squared. So we do want this ratio here. To simplify that, we copy the numerator, turn the vinculum into a dot, and we flip the denominator. So we get 2 pi r cubed over 9 pi r squared. The pi's cancel out. The r squared cancels out with 2 of the r's in the r cubed, giving us this 2/9r. Okay, so that's part A. And then moving on to part B, we're looking at the cylindrical tank. So a couple things we need to know about cylinders is that the volume of a cylinder is pi r squared h. In this case, h is also r, so just substitute that in and get pi r cubed, which is how I got this one. The surface area of a cylinder is 2 pi r squared, 1 pi r squared for the top and another pi r squared for the bottom. Plus, we're going to add in the surface area of the sides or the nape of that cylinder. And that comes from h times 2 pi r. Well, we know that h is r, so this really becomes 2 pi r squared because we're substituting r for h. So we get 4 pi r squared for the surface area. And then just like we did before, what we want to do is we want to make a ratio of the volume to the surface area. So that volume is pi r cubed over 4 pi r squared, which is why I picked this one. And that simplifies where the pi's cancel out, the r squared cancels out with 2 of the r's here, so we get r over 4. And then you would just need to compare 2/9r versus 1/4r. Remember the 2/9 is for the hemisphere and the 1/4 is for the cylinder. Which one has the highest volume or highest ratio. So which one of these ratios is the largest ratio? So hopefully that will help you out with your remaining questions on 8.4.26. If you have any other questions, I can make another screencast like this for you. Just let me know.